let's talk about the environment itself and controls we can put in place. You have to look at what the current environment is, obviously, because you're going to be introducing something new to it. Have there been instances where new software has stepped on the old environment? Absolutely. An open source environment, it's where you have the code. It's where you can look at everything. Those are becoming more common. They've been fairly rare up till now. Who works in a Linux environment? Good. And you have access to all your code and your instantiation of it?
For the operating system, yeah.
Okay. All right.
There's some tools you won't because they're not actually open source.
They're proprietary? They're, yeah. Okay. All right. But a lot more entities are going that way. And not just for the software, for their data as well. I'm not sure if it was the city of Oakland or the city of San Francisco, but they took their non-private data and just put it out, just made it open source, just published it, and said anyone who can come up with tools to aggregate and and analyze this, knock yourself out. And within days, crowdsourcing developers had come up with new ways of creating interfaces and digesting it. Some of them were selling, of course, these interfaces. And it was as if the new piece of software had been developed without having to submit any contracts, without having to put it out to bid. It was pretty interesting. Again, the language thing is going towards easier. Have you used Visual Basic since having used Pascal? Which do you prefer using?
Visual Basic is easier.
Yeah, a lot easier. It's a GUI interface, right? I mean, it's just a different way of thinking about it, and it's simpler. Gabe, you know SQL, right?
Yes.
Yeah. Is that easier or harder than command line programming?
It's easier.
Easier.
Yeah. Easier, yeah.
Good. Who knows binary? We all know binary. Zeros and ones. The computer itself doesn't distinguish between the data and the program. It's all zeros and ones to the computer. It's only different to us. So when it comes time to securing this stuff, you have to ensure that there's ways that these things are stovepipe, that the computer treats the data and the programs differently. It secures them in different fashions. Manual source coding is what? Other than archaic. What is it?
Talking like assembly?
Straight
in opcodes?
You lost me. Sorry.
Basically writing straight out almost machine language.
Yeah. Just typing it in, right? Yeah. Compiling it is coming up with those objects, running it through another program, and making sure that it's put together properly. And interpreted code. What's interpreted code?
Processed on the fly. It says processed on the fly.
Yes, yeah. It's as you're creating it, right? And those are the nice interfaces. That's the modern stuff. Good. Whole bunch of threats. All of these things, and we're gonna go through each of them in terms of software. Some of them you've already seen from other perspectives, so we won't dwell too long on those. Sorry, we got a repeated slide there. The more code you have, the more risk you have, which is completely intuitive. The more operations you have, necessarily the more risk you have. We talked about the CMM and how we can gauge on a scale of 0 to 5 how good our environment is. This is a perfect place to do it. It's designed for the software development. Iterative procedures so we can make sure that we know what level we're at. ISO 9000, anyone know what the 9000 is? 9000 series? It's quality, isn't it? ISO 9000 is quality. It's the standard for making sure that the process is documented, that the process is repeatable, that you have a standard process in place as opposed to doing it in an ad hoc fashion. Java. What is Java? What is Java?
Language.
Say again?
Programming language.
Who said coffee? That's worth it, too.
It's always on the book.
Okay, good.
It is.
Good. Yeah, Java is also Java also runs scripts in a way that mimics the system itself. The class loader is something that treats Java executables as different from or independent of everything else on the machine. It runs them anyway. The problem with that means that it can call on functions that you didn't necessarily want to do, that it may be locked down on your machine, but it's not locked down in Java. Anyone work with Java at all? Good. You have these, you've seen these problems, seen these flaws?
I haven't done it in a while, but yeah.
Yeah.
Yep, same.
Object-oriented programming. For years now, I've been hearing that this is the way we're going, that we're going to do a lot more object-oriented programming, that this is the wave of the future. Anyone familiar with this at all? What's it all about, Frank?
It's about having classes, and really hard to explain, actually.
Okay, all right, fair enough. Dan, want to take a crack at it?
It's about classes.
Good. Andy, is it about classes?
It's about having different entities.
It's
that
about classifying
work
your
together.
data.
Okay, all right, good.
Not chunks and not impact the
And also having functions to call those classes.
Okay, okay, all right. All of those things. It's about the data being able to have functions in itself, that the object that it's being stored in can run, can do some sort of function, right? Yes. Yeah. Instead of running an application to call the data itself has some functionality to it. We talked about you assign the data to classes. The object is going to be independent of other data because it is the data. You're inheriting security classes from whatever object that has been classified as, right? Okay. Polymorphism. Sounds like that's another big word, Andy. Because the data are assigned classes, even though they're similar objects, they might run differently. They might have different sets of functions assigned to them. And polyinstantiation, another huge, fun word to say. It allows the same data to be stored in different objects in different classes, so that data might be read differently by different users or manipulated differently by different users at a different classification level. I get that right, pretty much? Good. Cool. Distributed object-oriented, you got them spread across various machines. Why would you want to do that? Why would you want to do that? Why wouldn't you have them all in one place?
Single point of failure.
Okay, good, good. Excellent.
That's what I was going to say, availability.
Availability, good, all right. And sometimes it's just more efficient than having everybody call on the same machine at the same time, right?
There are essentially ways to be able to do programming across a network. So you can call classes or objects, functions, whatever, that are on a different machine.
Good. Good. Brent?
No.
No? Good. Excellent. Thank you, Dan. Good stuff.